Welcome to this video on the topic of exponential functions. In this video, we're going to have a look at what is an exponential. Now, an exponential is a mathematical statement where a quantity is raised to a power. If we draw our attention to the mathematical statement we see here, this is an exponential statement. The reason it's an exponential statement is because of the components it's built of. The first component we have over here, we call this the base. And the second component that we're working with, this x over here, we call this one of three names. We might call it the power, we might call it the exponent, hence the name exponential, and we may also call it the index. So an exponential statement is whereby we have a base raised to a power. Now this is simply a shorthanded way of representing successive multiplication. We've been dealing with statements like this since year 7. Now in terms of dealing with numerical quantities, we turn our attention to these quantities over here. Let's have a look at how they are evaluated, or how they can be interpreted and then evaluated. So we have 2 to the power of 1. We could evaluate this as simply 2 with an implied 1, so we just scrap the 1. So 2 to the 1 is simply 2. 2 to the power of 2 is rewritten as 2 times 2, and that is represented as 4. 2 to the power of 3 is 2 times 2 times 2, which is evaluated to be 8. So what we're seeing going on here is successive multiplication. Building upon this, we have 3 to the power of 2, you probably guessed it as 3 by 3, and therefore 9. And 3 to the power of 3 is 3 by 3 by 3, and that's going to equal 27. Now moving to something a little bit more abstract, a statement containing algebra. We treat this exactly the same way, however we're limited to our ability to evaluate the quantity itself. So x to the power of 1 is simply written as x with the implied 1. We don't write the implied 1, we just leave it like x. Furthermore, x squared is simply rewritten as x times x, or you could write it as x. Moving down, we have x to the 3. Moreover, it's written as x. So basically, all we've done is we've moved away from our conventions our year 8 teacher would have insisted that we work with, to moving to these conventions here to understand what this power actually does. Now powers themselves are not restricted to only being integers, rather we can also express other quantities within the power. These quantities could be fractions, 0, decimals, as well as negative numbers. Now in terms of thinking of powers as we've seen over here, we have to think in more abstract terms. In the context of general mathematics, or in the context of stage 1 general mathematics, we can usually get away with just using our calculators when we see these sort of problems over here. But just as a reference, let's go through some of them. So if we have an example such as 2 to the power of 0, it's going to be 1. X to the power of 0 is going to be 1, provided that the value of x itself is not 0. And finally, this puzzling looking expression over here is going to be evaluated as 1. The reason for that is that anything raised to the power of 0 will equal 1, provided that the quantity being raised, or the base itself, is not 0. Going to something a little bit more abstract, we have fractional powers. 9 to the power of a half evaluates as 3 if we threw that in our calculator. 2 to the power of a half evaluates to the value of the square root of 2. And b to the power of m divided by n is a really odd one, in that it's going to evaluate as the nth root of m. So, m. So something rather unusual we're seeing here. Again, we don't really have to know why this is. We just have to know that if we see something like this, we'll just deal with it using our calculator. So observe 9 to the power of 1 divided by 2 is indeed 3. 2 to the power of 1 divided by 2 is going to be root 2. And I can't actually put this one in my calculator. But say for example we wanted something interesting. We know that 3 to the power of 3 is 27. So therefore if we did something unusual, such as, let's go 27 to the power of 1/3 is going to be 3. Or we can do something like the cube root of 27 is also 3. So again, we don't really have to understand why this is, we can just accept it, and when we come to these sort of quantities, use a calculator. Then moving over, we have negative powers. The way in which we deal with these is we get our base, we throw it under 1. Again, we get our base and we get a power if it was positive and throw it under 1. So first one is 2 to the negative 1, the 2 just goes under a 1. 3 to the negative 2, we get a 1 and we throw 3 to the 2, so 3 to the positive 2 under the 1. And following this convention, we're going to do the same. We go b or 1 and then we put the b to the x downstairs. Now building upon this topic of exponentials, we're moving towards the idea of an exponential function. Now an exponential function is a rule where a quantity undergoes successive multiplication. This is usually of the form y equals a multiplied by b to the power of x. Now all of these components in this equation here have particular names we can assign to them. So x of course is the same as before. We're going to refer to it as the power, or finally the index. The b itself is still going to be referred to as a base. A itself has a special name as well we can give it. It's got many names. Some people call it scaling factor. In other courses we call it the dilation factor. In the context of exponential functions and its current location, it's actually a vertical dilation factor. And finally, we have y over here. This is simply the result, or we could call it the subject of the equation, or the function as we like to call it. So we've got y equals a multiplied by b to the power of x. Now this also, as well as having an algebraic representation which we can see, it's also got a graphical representation, but we're not going to touch on it in this video. That will be for the next video. But what we are going to do with it is we're going to have a look at the behavior of a function that looks a little bit like this. What we are going to do is take it from its algebraic representation down here to a numerical representation using a table of values. Now to help me along, because this is still pretty new, looking at it at this point in time, we're going to use our technology to aid us. So I'll clear all memory. I'll take myself into matrix mode, clear memory. Then I'm going to key in the function, so it's going to be everything on the right. So we're doing 2 to the power of, and we'll start from 0 here. Now because this is to a power of 0, I'm expecting a value of 1 as what we get. Moving across, we're going to go 2 to the power of 1. We expect that to be 2. 2 to the power of 2. Simply 2 squared, which is 4. And then 2 to the power of 3. So what we can see is that the numbers are growing at a growing rate, or they're increasing at an increasing rate. So for a step of 1, we're seeing a step of 1, then we see a step of 2, and a step of 4. So the gap between the numbers increases. This is a symptom of an exponential function. Now let's do the other half of the table. We have 2 to the power of minus 1, come out to be 0.5, or we can write it as a half. Moreover, we can go 2 to the power of minus 2, comes out as 0.25, or we can write it as a quarter. And then finally, 2 to the power of 1 minus 3 is 0.125, also written as an eighth. So a bit of a pattern you can see here. On either side of the 1, you have 2, then you have a half, you have 4, then you have a quarter, an 8 or 8, and then you have an eighth. So everything's growing at an increasing rate. Alright, let's have a look at B. In this case, we're dealing with a dilation factor of 2 now. So if we think about it, comparing it to what we had over here, we're expecting everything to be scaled up by 2. So if we have 3 to the power of 0, it'll come up as 1, but we're scaling it by 2. So it's 2 times. This will be 2. Changing it to 1 comes out as 6, 18. So it's growing at an increasing rate. Now throwing in the negatives, we have a disgusting looking irrational number, so we'll represent it as a fraction. Another irrational number, 2 on 9, and a really filthy number. So what you can sort of perhaps see is we've got the dilation factor represented at the top of the fraction here, and underneath we're getting the exponential over here, so 3 to the power of something. 3 to the 1 is 3, 3 to the 2 is 9, 3 to the 3 is 27. So once again what this is illustrating is that we're growing at an increasing rate. So in summary, what we had a look at in this particular video was we had a look at the idea of an exponential, that being a mathematical statement where a quantity is raised to a particular power as shown in this form here. Moving down, we had a look at some abstract examples of what sort of powers we can get, so unusual powers. Again, we don't really need to understand why it is the way it is. Rather, we just need to know how to deal with it, and in most cases we'll be able to deal with it using our calculator. In the case that we're dealing with some algebraic problems over here, there is a way to also do that in the calculator, but that's coming up in later lessons. And then finally, we had a look at this idea of an exponential function. A function whereby we have exponentials embedded in them. So we're not getting these linear lines anymore, rather we're going to get something different based on what we can see with these tables.